Imagine peering so deep into space that you're looking back almost to the beginning of time. Now imagine finding not just one or two, but hundreds of galaxies, bright, massive, and mature, when the universe should have been little more than cosmic dust. That's exactly what NASA's James Webb Space Telescope has just revealed, and it's left scientists shocked, speechless, and scrambling to explain how this is even possible. Since its launch, the James Webb Space Telescope has been rewriting the first chapters of cosmic history. Its primary mission was to peer back to the cosmic dawn, the era when the very first stars and galaxies ignited. Armed with unparalleled infrared sensitivity, Webb can detect the faint ancient light that has traveled for over 13 billion years. It's not just breaking records, it's exploring a period of time we've never seen before. And what it found there has left astronomers both thrilled and profoundly perplexed. In deep field surveys like JADES and SEERS, which involve staring at small patches of sky for hundreds of hours, Webb uncovered a cosmic surprise. It found hundreds of surprisingly bright and massive galaxies that already existed just 300 to 500 million years after the Big Bang. This time frame is shockingly early, a cosmic blink of an eye after creation. To truly grasp how radical this is, imagine the universe's 13.8 billion-year history compressed into an 80-year human lifespan. In this analogy, these galaxies Webb found are appearing when the universe person is barely 2 years old. But they don't look like 2-year-olds. They look like fully grown adults. Our established models predicted that the first galaxies should be small, clumpy, and chaotic, seeds that would slowly grow over billions of years. Instead, Webb is finding galaxies that are already large, have developed structures, and are bursting with a surprising number of mature stars. They are far too massive and well-ordered for their age. The current record holder for this cosmic conundrum is a galaxy named JADES GSZ 14-0. The Z14 refers to its redshift, a measure of how much its light has been stretched by cosmic expansion. A higher redshift means we're seeing it further back in time. At a redshift of over 14, we are witnessing this galaxy as it was just 290 million years after the Big Bang. It is astonishingly luminous, implying a mass of hundreds of millions of suns, challenging our models of early star formation. These discoveries have ignited a firestorm of debate. How did these galaxies get so big, so fast? Did the first stars form much more efficiently than we thought? Or could our fundamental understanding of cosmology, the very rules that govern the universe's evolution, be incomplete? These impossible early galaxies are a direct challenge to our standard model, forcing us to reconsider the story of creation. For decades, our understanding of cosmic evolution has been guided by a single powerful idea, the lambda-CDM model. It paints a picture of galaxy formation as a slow, methodical process called hierarchical assembly. Think of it like building a skyscraper brick by brick. Tiny clumps of dark matter, the invisible scaffolding of the cosmos, would first pull in gas. These small pockets would ignite with the first stars, forming dwarf galaxies. Over billions of years, these smaller structures would collide and merge, gradually building up into the grand galaxies we see today. This model has been incredibly successful, but when the James Webb Space Telescope opened its golden eye to the cosmic dawn, the picture it revealed sent shockwaves through the astronomical community. Here's the problem. According to our best models, the galaxies Webb is finding simply shouldn't be this big, this bright, or this evolved so soon. Building a galaxy takes an immense amount of time. First, gravity needs to slowly gather vast reservoirs of hydrogen and helium gas. Then, that gas has to cool and condense enough to ignite the nuclear furnaces of countless stars, a process with its own cosmic speed limit. Finally, creating well-ordered structures like a rotating disk requires billions of years of gravitational settling. According to our timeline, at just a few 100 million years after the Big Bang, we expected to find the cosmic equivalent of infants, small, messy, irregular collections of the first stars. But Webb is showing us galaxies that seem to have fast-forwarded billions of years. Instead of cosmic toddlers, we're finding what look like fully grown adults. Some of these galaxies already contain tens of billions of stars, making them as massive as our own Milky Way is today, when the universe was less than 3% of its current age. To form that many stars that quickly is a profound puzzle. It would require converting nearly 100% of the available gas into stars, with an efficiency that defies our understanding of astrophysics. It's as if someone hit a cosmic skip button, and galaxies matured overnight. This stunning discrepancy has forced scientists to question the very pillars of cosmology. Could our understanding of dark matter be wrong? The standard model assumes cold dark matter provides the gravitational seeds for galaxies. Perhaps those seeds were simply much larger, much earlier than predicted, giving these galaxies a massive head start. Or did the early universe grow stars more efficiently than we thought? Maybe the first generation of stars formed in a hyper-efficient burst, or the feedback from supernovae was less disruptive than our models suggest. And then there's the most fundamental question: are our cosmological models missing something? It's a moment of crisis and opportunity where these new observations could rewrite everything we thought we knew about our cosmic origins. In some studies, astronomers estimate that Webb may uncover over 750 candidate galaxies from these ultra-early times. While not all are confirmed yet, the sheer scale is rewriting our timeline of cosmic history. Instead of a slow dawn of light, the early universe may have been crowded, energetic, and alive with stars. If these early JWST observations hold true, the implications are revolutionary. It's not just about tweaking our cosmic models, it's about potentially rewriting the opening chapters of the universe's history. The very foundations of modern cosmology are being shaken. It could mean several astonishing things. First, that the earliest stars and supermassive black holes ignited almost instantly after the Big Bang. Our standard model predicted a much slower, gradual process, but Webb is seeing objects far too massive and mature to fit this timeline. It suggests the universe was incredibly efficient at building colossal structures right from the start, challenging our fundamental theories of star formation. Second, the seeds of galaxies like our own were planted far earlier than expected. The prevailing theory was that galaxies grew hierarchically, with small structures merging over billions of years. But these early massive galaxies suggest a different story. Perhaps enormous clouds of gas collapsed directly into large, well-formed galaxies, skipping the intermediate steps. The cosmic garden bloomed furiously from the beginning. This leads to a third consequence. The cosmic dark ages may have been surprisingly brief. This was the epoch before the first stars switched on, plunging the cosmos into darkness. If stars and galaxies were already blazing into existence so early, they would have begun reionizing the neutral hydrogen gas around them much sooner, ending the darkness and ushering in the cosmic dawn ahead of schedule. And finally, the most tantalizing possibility. To explain how so much structure could form so quickly, some scientists suggest our physics is incomplete. Perhaps dark matter behaves in unexpected ways, or the initial conditions of the universe were different. We may need to revise our standard model of cosmology. This isn't a crisis, but an incredible opportunity. A new mystery for a new generation of explorers, handed to us by Webb. So no, James Webb hasn't found galaxies beyond the edge of the universe, but what it has found is almost as shocking. A universe that grew up far faster, far brighter, and far stranger than anyone believed. The more we look, the less we understand. And that's the most exciting part, because with every strange discovery, we're one step closer to uncovering the true story of our cosmic origins.